Greetings, mathematicians. All right. I did not forget the title this time. Unit 5, Lesson 3. Too large, too small, or just right. Um, you've got space over here for the date of whatever day today is. Our objective, I will explore ways to adjust the estimated divisor when it's too small. Estimated. In our last lesson, we kind of looked at what it means to estimate. So we're looking for a number that is near the number we're working with. Divisor, remember that's the outside number. All right. Read the objective with me. I will explore ways to adjust the estimated divisor when it is too small. All right. So taking a look at our sample problem here, I'm going to zoom out and get some more perspective. Talking about the divisor. Now, this one is tricky because what's tricky about the number 85? Well, we're halfway between 80 and 90. So typically, I like to round up. So I'm going to pretend it's 90. Now, if we work this problem out, we need to, much like the title says, too large, too small, just right. I'm going to do a big thing right here. I want to overestimate. Can you say with me, overestimate? We're going to go big. Now, I'm going to go digit by digit here. Can 85 go into 5? No. All right, guys, we are going to overestimate, and we're going to take our 85. We're going to call it 90. Can that go into 5? Can 85 or 90 go into 5? Absolutely not. What about 51? No. So we're going to have to go all the way to 518. We don't have our 90s or our 85s memorized. So what we can do is, let's take a big number like 10. 85 10 times, which the answer is 85 with a 0 at the end. So 850. Is that too big, too small, or just right? When we compare 850, is that too big, too small, or just right? Well, it's absolutely too big. Also, I cannot fit the number 10 over the number 8. I'd have to use a single digit number. So let's make our overestimate 9. 9 times 9, 81 with a 0, 810. That's way too big, right? So let's see how much bigger it would be for this. So I'm going to multiply 9 times 80, 9 times 5. So our 9 times 80, we've got 72 and 0, 720. 9 times 5, we've got 45. Let's add them together, 720 and 45. We end up with 765. We cannot subtract 765. 9 is much too what? Too big or too small? That's right. It's much too big. Way too big. All right, so I'm going to readjust. Got the same problem. I'm going to take half of this, or roughly half of this. Let's go with 5. Let's see if 5 works out. So again, 85, we're going to round it to 90. Can't go into the 5, can't go into the 1, can't go into 51, must go into 518. So let's take a smaller number. So we're going to find our answer somewhere between these. One will be too big, one might be too small, or maybe maybe this is just right. We try it out. So 5 times 90, 5 times 9, 450. Ooh. So this tells me we're getting closer. All right, let's see. What is 5 times 80? And 5 times 5? 5 times 8, 40. Bring down our 0. We've got 400. 5 times 5, we got 25. Let's put it in there, 425. Now, what do you notice? Can we take 425 away? Absolutely. But could we fit another 85 in there? Now, if we put another 100 in there, we're at 525. That's actually pretty close to 518. So there's a good chance we just need one more. So that one was too big. This one is too what? Too small. Now we're getting pretty close. So if we just add 85 to 425, what do we get? Let's take the 80 from here and add it to 425. We're going to get, what, 510? Let's try it out. Let me rewrite the problem. 85 on the outside. Now you're going to notice this is a lot of work. This is not something we get very quickly. This is going to take some trial and error. We're going to go too big. We might end up too small, but we're going to find the right answer. So we're going to increase this by 185, meaning not 185, but one set of 85. So we were trying 5. Let's go up to 6. 6 times 80, 6 times 5. 6 times 8 is 48. Bring down our 0. 6 times 5. We end up with 30. Put it together, we get 510. Subtract. We can do that. This is the just right number. It is close to 518 without going over. Could we fit another 85 in there? Absolutely not. But this is where we need to this is all the work we need to do to get to that first number. Yes, I know this is a lot of work. And that's okay. We need to do a lot of work sometimes. So let's work it out. 518 minus 510, easy peasy. We've got a 5. Bring down, I'm sorry, we've got 8. Bring it down, 85. How many times is 85 going to 85? Bingo, 1 time. Subtract out, 0 remainder. Fantastic. That is a lot of work. Let's try another sample. If you need to pause at any point to get caught up, feel free to do so. All right. Moving along, I've got 2 more sample problems. I'm going to zoom in at the top. So our dividend is 1,380. Our divisor is 15. So again, these are those 5 numbers. We're halfway between 10 and 20. Typically, we round up. So we're going to go 20. That's going to give us too high. If we round it to 10, it's going to give us a too low estimate. So let's see. Can we go into 1? No. 13? No. We're going all the way to 138. Now, let's see. Let's pick a number here. If we multiply by 10, that's 200. That's way too many. Let's go with the same numerator as the last time. Let's try 6. So again, 6 times 20. 6 times 2 is 12. With a 0, 120. Okay, hey, that gets us under. Let's see what happens when we multiply 6 by 15. And again, 6 times 15 is the same as 6 times 10 and 6 times 5. 6 times 10 is 60. 6 times 5 is 30. We are under, right? So 60 plus 30 is 90. We are under. Can we fit another 15 in? I think we could. How many more can we fit in? So at this point, I could rewrite the problem and just keep going up by one number, or I can just simply take my 90 and I can add 15 to it. What's 90 plus 15? That's right, 105. So that would be the difference of our quotient starting with the number 7. I'm going to put a box around it. Now, if it was going to be an 8, we'd have to add another 15. So we can take our 105, 105, let's add 15 more. That gets us to 120. We're still under the 138. So our quotient could begin with the number 8. We're getting close. Can we fit another 15 in between 120 and 138? Absolutely. So if our quotient begins with 9, let's take our 120. Let's just add another 15. That was sloppy. And we get 135. Bingo. Now we're there. Now, I can keep working this out, but I'm not. We know the quotient has to start with not a 6, it's going to be a 9. So 9 times 10 is 90. 9 times 5 is 45. That gets me to my 135. So let's get rid of this. 135. Subtract 30. How many 15s going to 30? Easy peasy, that's 2. So our quotient is 92. 0 remainder. All right. Let's try one more. Now, same deal. We've got a 5 over here. Let's call it 90. Can that go into 6? No. 60? No. 603, that's tough. Now, I know we already estimated our 85 to be 90, but 90 is getting real close to 100. And 603, there's only 600s in there. So it could be 6. I'm going to go with a safe bet and stick with that 6. 6 times 9. We get 54 with a 0, so 540. That's under. That's pretty close. Let's see if it works with our 85. Again, 6 times 80, 6 times 5. And I'll do this off to the side. 6 times 80, 6 times 5. Bring it down, easy peasy, 30. 48 and a 0. Let's add them up. 480 plus 30. That puts us at 510. Can I fit any more 85s in there? If you're not sure, take your 510, bring it off to the side, switch up my color. I'll bring it off to the side, move it over, and I'll just add another 85. So that's as if my quotient changes to the number 7. I've got it at 6 right now, but if it were 7, let's see what happens. 5 plus 0 is 5. 1 plus 8 is 9. 595, I'm just under. So this is only 1 away. I was 3 away. Here we are so close. We're still doing the work, a little bit less work here. So let's switch it up. That becomes a 7. We've got our 595. It's easy enough to alter here. 603 minus 595. So 3 and 5 makes 8. So we're 8 away. Bring it down. Oh, hey, how many 85s go into 85? That's easy peasy. When you notice a problem starts to work together too easily, that's a sign that you're on the right path. 1, subtract out, we get a 0 remainder. Our answer is 71. Now, again, this is going to be a lot of work. But we need to do this work to show our understanding of how division with bigger divisors works. All right. There are some sample problems for you on, let's see, page 103 in your skinny workbook. I want you to pick 4 problems and work on them. Let's see, one of those problems needs to be a word problem. All right. And after you complete these, you can come check in with me. And our homework this evening will consist of Think Central. It's working again. And that homework is, oops, let's see if I can zoom over. That homework is going to be called Unit 5, Lesson 3, PMT, Personal Math Trainer. All right. Thanks for watching, guys.